Hi, my name is Thor and I'm developing Scorching Engines, a game set aboard a giant vehicle in a frozen wasteland where you have to fight for your survival, with the help of turrets and your own two hands, wielding a gun of course. And soon the raiders attacking you will have animated models and more intelligent behavior. Additionally, the game has a Steam page now, so if you're interested in the game it would be greatly appreciated if you wishlisted it. A common way of modeling artificial intelligence in video games is with the use of a state machine, where you define different states that your AI can be in, which for the vehicle raiders in my game is currently either an idle state, a chase state, or a circling state. Additionally, you also define the transitions between these states that mark what component changes signify a change of state to a specific state from another state, where you then can have different systems working on different states. With ECS, all the systems work on a query basis, where they query for all entities matching their components' requirements and then they only perform work on them. This means that I can very easily have systems that only affect a specific set of entities by only querying entities that match the system's desired state, where the states are signified by a component being enabled or disabled on the entities. Additionally, this means that I can have different behaviors for different enemy types, despite them being in the same state. For example, I created 3 enemy types by having an empty tag component, a vehicle, humanoid and bug, and then I can just have 3 different jobs running in the idle system, one for each enemy type. And if I want to have another enemy type, I just add another component and create a new job with a new query. I haven't added the bug enemy type yet, but an example implementation would look like this, where each enemy type has a different detection range to the player, where once the entity gets closer to the player than a certain distance, we disable the idle component and enable the chase component, signifying a transition from the idle state to the chase state. This means that the next frame, the entity will get processed by the chasing system instead of the idle system. I could also use this to create a large vehicle enemy type, where the enemy has a blocking tag, which represents things that the vehicle cannot drive through. I did a simple proof of concept implementation for this enemy type by just taking a normal enemy vehicle and making it 3 times as big, adding the blocking tag and removing the movement from the enemy. Where you can see that if it's in front of the player's vehicle, you cannot drive forward, visualized in the editor by the green raycasts in front of the vehicle. We then schedule a new chase job for this tag combination, where the new chase behavior would make it so that the large vehicle tries to place itself in front of the player's vehicle and therefore stops the player from driving off, acting as a mobile roadblock. Due to how ECS works, I can also update the systems that affect certain states in their own interval, so that idling enemies, for example, don't update every frame and therefore affect the game's performance less. Where setting the update interval to 1000 milliseconds, it only updates once a second. The only problem with this design is that each of these states is a new component, so the prefabs for my enemies start to become pretty cluttered. Although I shouldn't really be complaining, as I can very easily make the base enemy authoring component add all of the required state components instead. One benefit with using Unity dons is that since these state components are empty, i.e. they are only tags, they don't affect the memory footprint of the entities and therefore don't change the amount of enemy entities per archetype chunk. Where an archetype chunk is a grouped collection of all entities with the same components. What this means is that having entities that use less memory leads to more entities in an archetype chunk, since they are limited to 16 kilobytes per chunk, which leads to noticeably better performance. And since these state components are enableable, I never remove or add them, I just turn them on or off. Which means that the archetype of an enemy never changes, so all the enemies of the same type are in the same archetype chunks, regardless of their state, leading to less memory usage, better CPU performance, and a happier me. I could, however, instead of having a tag component for every state, have a single component with a state variable, where systems check that tag to prevent the wrong job from running on an entity, but doing this would be worse for performance as there would be many systems running on all enemy entities, and all checking the same state before running the jobs. Which means that the systems can't run in parallel, since they all have to wait in turn in case some other system changes the enemy's components. This won't happen with the state components due to the components-based queries used for systems, as no two state systems will run on the same entity during a frame. Luckily, it's very cheap to have systems filtering entities based on the enabled components, as it's very cheap to enable and disable components. Unity themselves say that enabling and disabling components is a lot better than adding or removing them, as it can be many hundreds of times faster. I do, however, have a state component that is used to represent which animation should be playing, as checking which state component is enabled very quickly balloons out of control and would be very bad for performance. As if we have 10 different states an enemy can be in, then for every enemy we have to check 10 different components if they are enabled or not. As there's a system running for all enemies regardless of which state components they have, but it needs to know which state components are enabled. Therefore, it is cheaper to have the state systems specify the new state when enabling or disabling state components. This also makes it easier to debug, as we can just check the state variable on enemies. As part of this new state machine designed for enemies, I also refactored the so-called AI for my vehicle enemies, although they are way more artificial than intelligent. This refactor has made the code less spaghetti, but also more importantly made it possible to make the enemies more interesting to fight. This new design for the vehicle enemies have made it so that when the player's vehicle is moving at a sufficiently high speed, the enemies will pick a side of the vehicle and follow along, swerving around a bit, and once the vehicle stops, they will start circling like vultures. The idea is that once the player's vehicle stops, the enemy vehicles will stop to let out some humanoid raiders on foot and then start circling the vehicle. I have done a rough implementation for this feature, but it needs a lot of polish for it to look good. Luckily, that is a task for future me. Doing animations in Unity Dots is pretty annoying as there is no built-in animation framework that works well, as the current official Dots animation has a to-do instead of instructions. Editor note here, according to Wayback Machine, the to-do was apparently fixed with some instructions, but the package seems to be gone now, so I have no idea. There are currently two different ways to do animation in Unity Dots, either by using a hybrid approach or finding a nice third-party solution that does what you need sufficiently well. Where a hybrid solution is where you have a game object being animated, tracking the position and rotation of an entity all the time, and then you trigger animations on the game object from ECS systems. The only problem is that this is a tedious approach, as there's a lot of manual work needed to get everything syncing up correctly. Additionally, you can't have ECS colliders on game objects, and therefore you have to do a lot of work having the entity colliders synced up with the game object bone positions. Which means that if you need the entity representation of a raider to actually be where the animation is, then it is a lot of hassle. Which in my case is something that I need to have, as I can't have the colliders be T-posing while the animation is running around, as you wouldn't know where to shoot when fighting the raiders. Therefore I had to go with a third-party solution instead, where I tried to use the Kinemation framework by Dreaming Latias, as well as D-Motion by Dichichi, as they're supposed to have great performance. But unfortunately I could not get it working, as I was using a too new version of entities, and even after trying to downgrade I had some incompatibilities. Therefore I caved and bought an ECS animation package by Rukhanka on the asset store, since I had been looking at it for quite a while and it's got some impressive features with more on the way. One major benefit of using ECS-based animations instead of the hybrid approach is that all my colliders are automatically synced up with the animations, since I can just attach them to the bones. Where I now use a capsule collider for each bone, since it is sufficiently accurate for my needs while providing great performance, and it's also sufficiently accurate for CSGO, so that's gonna be good enough. In order to make it so that the enemy has one health pool, instead of each limb having its own independent health, I had to create a component that acts as a pass-along, where they just send the bullet collision forward to the main enemy. This is done where if a bullet hits an enemy limb with a damage pass-along component, then instead of doing all the damage and armor checks against the limb, it's done on the main entity, i.e. the raider. Additionally, there is a damage multiplier parameter, so that if you shoot the head of the raiders, it can do more damage, or torsos taking less damage. Therefore, I can also add a headshot multiplier to guns, so that their bullets deal additional damage to a specific body part, such as sniper rifles doing 10 or 20% more headshot damage than normal bullets. As you can see in this small benchmark I did, where I compared 100 animated entities with ECS colliders to 100 animated game objects with game object colliders, you can see that there is a pretty large difference in performance, where when comparing entities to game objects, both with colliders tracking the animations, the entity approach has a much more stable and higher frame rate, with the game objects being pretty stuttery, and that is without the game objects being capable of taking damage. It is, however, important to note that I'm using a special fork of Unity entities and Unity physics by Turtle that is made to be sync-less. What this means is that there is less time spent waiting for parallelized jobs to finish, and therefore it provides a higher and more stable frame rate compared to base Unity entities. Therefore, this isn't a straight game object versus dots comparisons for animated characters with colliders, as it isn't a default dots that I'm using, but it still shows that dots is a lot faster. However, as you may have noticed, the enemy walking animation is a bit weird, as the feet don't correctly line up with the terrain that they are walking on, which is something that I will be addressing. I am, however, waiting for Rukhanka to update the animation package, as inverse kinematics is coming in the next release, so that we can procedurally animate enemies. Additionally, I can also use this to animate some arms for the player so that the guns aren't just floating. However, luckily for me, Ragdolls are already implemented into the version of Rukhanka that I'm using, which means that after a few issues I had to iron out, we now have raiders that become Ragdolls on death. However, as you can see, the Ragdolls sometimes go a bit crazy, which is something that I need to fix, as well as the fact that the raiders sometimes get elongated upon death. The idea is for the Ragdolls to be lootable, so that you can get ammo from the raiders and perhaps also guns, but for the moment they just despawn after a little bit. I have done a lot more work than what I've shown in this devlog, but a lot of the stuff that I didn't fit well into this devlog, and has been postponed to the next devlog, because otherwise this one would be way too chaotic, as it would be focusing on a lot of different smaller parts. For example, the muzzle flashes and bullet impact VFX, as well as the raiders shooting at the player. I can also tease a pretty major design revamp of the vehicle, including an interior. Although this is far from done, and it might also be a bit too big. You know what isn't too big, however? The amount of wishlists on Steam. But luckily you can fix that by going to the store page, linked below, and wishlisting it. And if you want to keep up with the development, then I'd really appreciate it if you subscribed. Also, thanks a lot for all of the support and friendly comments for the game's development, and if you have ideas for features or feedback, you can write a comment, as I'm always open to hearing what you guys have to say. Thank you all for watching, and I shall see you in the next devlog.